Hello everyone. Today we're talking about continuity. Now this is a term I've used in the past and your Algebra 2 teachers should have used it quite a bit in Algebra 2, but I'd like for us to review it a little bit because it's going to be important for the next set of material that we're talking about in pre-calculus. So the idea here, folks, is if the endpoints of two segments overlap on the same xy coordinates, then the functions are continuous at that point. That is to say, there is one line going through that point. We might still have an undefined open circle superimposed on a closed circle, but from us looking at it, it looks like one continuous line. Now in these sorts of problems though, you're not going to have the graph to work with, because from the graph you should be able to see fairly quickly, is it or is it not continuous? Rather, we'll be looking at the individual piecewise functions. And the steps for this is first we're going to identify the x value of the potential continuity. We'll then plug in the x value into both equations, and then if they're continuous, we should get the same values on both sides, or a case of 0 equals 0. If we get different values, they are not continuous at that point. Now, what do I mean by that? Let's take a look at example 1. Is the function k of x continuous at x equals -8? Well, first we identify what's the potential point of continuity. X equals -8. So now we're going to plug in x equals -8 into both the top equation and the bottom equation. But wait, there's no x down here. It's not -16x, it's just -16. And that's okay. Because when we go to set up our equations, we're still going to have on one side, the top equation, 3x plus 8. And on the other side, we'll just have the bottom equation, in this case, -16. Now we're going to plug in -8, our proposed x value, for the x value here. Well, 3 times a -8 plus 8 is equal to -16. Okay. -24 plus 8 is equal to -16. -16 is in fact equal to -16. So these two functions at x equals -8 are continuous because -16 equals -16. Let's take a look at another function. Example 2. We'll use a different color so we don't get them confused. Number 2, is the function f of x continuous at x equals 5? So, once more, we've got our top and our bottom. But just like before, one of our equations doesn't have any x values, and that's okay. We're still going to write this out as if testing to see if they're equal. So we have 16 is equal to 4x minus 4. Now we're going to plug in our desired value, x equals 5, into any x values we have. So 16 is equal to 4 times 5 minus 4. 16 is equal to 20 minus 4. 16 is equal to 16. They are continuous at x equals 5. Another one. Example 3. Is the function k of x continuous at x equals 4? Well, now we've got x's in both of our equations, and that's fine. our process still remains the same. So, let's draw that dividing line, just so we don't get things mixed up. Negative 3x minus 6 is equal to negative 8x plus 14. And we want to know, are they continuous? Are both sides going to be equal at x equals 4? So we're going to plug in 4 for our x's. Negative 3 times 4 minus 6 is equal to negative 8 times 4 plus 14. Well, negative 3 times 4, that's negative 12, minus 6 is equal to negative 8 times 4, negative 32 plus 14. So then negative 12 minus 6, that's going to give us negative 18. Negative 32 plus 14, that will also give us negative 18. So once more, both sides are the same. This is continuous at x equals 4. And folks, I get it. This example, the last two, they've been continuous. For now, it's easier to just show you continuity. All right, fourth example on this type of problem. Is the function g of x continuous at x equals 8? All right. Once more, we've got x on both sides. So let's write this out. 2x minus 8 is equal to x plus 7. Well, we're now going to plug in for a desired value of x equals 8. So 2 times 8 minus 8 is equal to 8 plus 7. 2 times 8, that's 16, minus 8 is equal to 15. Now folks, we could probably stop there, but let's just finish off the problem. 8 is equal to 15. 8 does not equal 15. So this is not continuous at that point. And folks, honestly, I can't spell continuously properly, so I'm just going to stop at not conti. Okay? You could also call this, rather, I'm fine with you calling it NC, not continuous. So, sometimes you'll be asked to evaluate whether or not two or more functions are going to be continuous at certain points. But other times, you might have to force a continuity. You might have to make it so that the two equations are continuous at a certain point. So let's take a look at that. Because yeah, other times you might be asked to make a function continuous at a certain point. This might look scary because it will look like there are two variables, but really there's only one. This is a two-step process, folks. First, we're going to substitute the x's into the function for the desired point, and then we're going to solve and simplify for any remaining variables. So, example 5. Find the value of k that makes f of x continuous at x equals 9. So, first things first, let's set up our equation. X minus 1 is equal to k. All right, so we have an x and we have a k. And it looks like two variables, but it's not. It's not because, if you remember from the prompt, we have to find the value of k that makes fx continuous at x equals 9. So right off the bat, we can substitute a 9 for that x value, and this becomes 9 minus 1 is equal to k, or 8 is equal to k, such that if k equals 8, this original function will be continuous at x equals 9. Let's take a look at another one. Same idea. Find the value of k that makes f of x continuous at x equals minus 9. So we're going to set up our equation. X plus 4 is equal to k. It looks like we have two variables, but because we're looking specifically when x equals negative 9, what we can do is plug in the negative 9. Oop, getting ahead of myself. We get negative 9 plus 4, and that's equal to k. Well, negative 9 plus 4, negative 5, is equal to k. Such that if k is equal to negative 5, this function is continuous at x equals minus 9. One last one, folks, and then we're done with the notes for today. Find the value of k that makes f of x continuous at x equals minus 2. And now we've got quadratic functions to worry about. But folks, don't worry about them, because we're still going to follow the same general steps. We're going to write this out fully. We have negative 2x squared plus 6 is equal to k. Once more, it looks like we have two variables, but we don't, because we're looking at this only at the point x equals minus 2. So let's plug in what we know. We have negative 2 times negative 2 squared plus 6 is equal to k. All right. Well, please recall your order of operations. PEMDAS. For me, it was, please excuse my dear Aunt Sally. We have our parentheses here. Parentheses, then exponents, then multiplication, division, addition, subtraction. So negative 2 squared gives us positive 4. So this becomes negative 2 times positive 4 plus 6 is equal to k. Negative 2 times 4, negative 8, plus that 6 is equal to k. Negative 8 plus 6, well, that's negative 2, which is still equal to our k. So if we have our k value equal to negative 2, then this function will be continuous at x equals negative 2. So folks, please try the practice problems on this. If you have questions, please shoot me an email or come to my tutoring. Take care.